the trust economy. When code becomes free, trust becomes the business. Flint West reporting. Section 1. Ladies and gentlemen, gather round, because what looks like a conversation about Robert F. Smith is actually a conversation about the death of one economic world and the birth of another. See, on the surface, this started simple. Who is Robert F. Smith? What does Vista Equity do? What kind of software do they own? Basic questions, respectable questions. But if you follow the thread all the way down, you realize you are not really studying a man. You are studying an era where software was scarce, an era where code was expensive, an era where institutions paid huge sums of money, not because software was beautiful, but because it was difficult to build, painful to replace, and dangerous to lose. That was the Vista era. That was the old kingdom. And Robert F. Smith understood that kingdom better than almost anybody alive. He saw that the real money was not in cute consumer applications, not in vanity technology, not in glossy toys for the masses. No, the real money was in the boring systems, the invisible systems, the software under the software, the digital plumbing, the machinery behind payroll, the systems behind tax compliance, the workflow engines behind hospitals, insurers, banks, logistics networks, school systems, human resources departments, procurement desks, and corporate reporting stacks. The deeper truth was simple. If an organization owns the software people cannot remove, then it owns the rent stream attached to modern civilization. That was the play. That was the insight. Investment firms did not need to invent magic. They did not need to become artists. They became industrialists. They bought enterprise software companies. They optimized pricing. They standardized operations. They pushed subscription models. They improved margins. They deepened lock-in. They raised recurring revenue. And then they exited at higher multiples. Beautiful, cold, systematic. The software equivalent of buying a factory, tightening every bolt, cutting every leak, and then selling it as a precision-engineered profit machine. That model worked because software lived in a world of scarcity. Scarcity of engineering talent, scarcity of implementation capability, scarcity of integration expertise, scarcity of trust. And when something is scarce, the owners of that scarce thing get paid. That's the first layer of the framework. Section 2. Layer 1. Software used to be scarce. That scarcity justified empires. It justified consultants. It justified six-figure contracts, seven-figure deployments, and decade-long vendor relationships. It justified the entire software aristocracy. But then something happened. And this is where the conversation stops being biography and becomes civilizational. Artificial intelligence arrived. And with artificial intelligence came the collapse of one of the oldest assumptions in software economics. The assumption that writing code is hard enough to protect incumbents. That assumption is now rotting in public. Because what happens when code becomes cheap? What happens when one engineer with artificial intelligence tools can produce what once required 20 engineers? What happens when a founder no longer needs a full engineering department to prototype, ship, test, revise, and redeploy a product? What happens when software supply explodes? You get abundance, and abundance is where old business models go to die. See, in the old world, code was an asset. In the new world, code begins to resemble a raw material. And when a raw material becomes abundant enough, the economic center of gravity moves elsewhere. This is the pivot. This is the pinpoint position. Artificial intelligence is commoditizing software creation, not software usefulness, not software demand, software creation. That distinction matters. Because many people hear that statement and immediately think software must therefore be finished. That is not the case. Software is not disappearing. Software is about to become more abundant than ever before, which is precisely the problem. The issue is not that software disappears. The issue is that software multiplies so fast, so cheaply, and so widely that code itself can no longer carry premium value on its own. That is what the earlier discussion kept circling. Not just the production of software, but the flooding of the zone. A good enough software flood. And once that flood begins, a number of old assumptions begin to fracture. Per-seat licensing starts looking unstable. Why? Because per-seat licensing was built for a world where human labor scaled software usage. 1,000 employees meant 1,000 seats. A bigger company meant more humans using more interfaces, more dashboards, more credentials, more departmental licenses. But what happens when artificial intelligence compresses labor? What happens when 10 people, supported by an intelligent agent stack, can accomplish the work of 200? The seat count drops. The old pricing spine weakens. This is not cosmetic. This is structural. If artificial intelligence removes headcount while preserving output, then a large portion of software as a service revenue logic comes under pressure. So the game changes. Software firms can no longer simply charge for people. They must charge for outcomes. They must charge for usage. They must charge for application programming interface calls. They must charge for verified performance. They must charge for delivered results. And that is a far harsher arena. Because charging for seats is easy. Charging for outcomes is war. Seats are administrative. Outcomes are competitive. The moment the model shifts from licensing an interface to proving a result, the industry enters the coliseum. And in that coliseum, every layer of overhead gets interrogated. Every premium gets questioned. Every middleman gets tested. Every moat gets measured against one uncomfortable question. Why should anyone pay this much if code is getting cheaper every month? That question is the acid. And it does not only reach small startups, eventually it reaches the giants. This content is brought to you by Bobby Gigs. Promote your brand here and reach a wide audience across platforms like YouTube, Instagram, and Facebook. Follow the links in the description to get started. Section 3. When code becomes free, trust becomes the business. Now, to be fair, the enterprise world does have defenses. This is where the discussion properly distinguished between consumer software and mission-critical systems. Because enterprise software is not simply code. That is the amateur mistake. Enterprise software is code combined with reliability, code combined with compliance, code combined with security, code combined with auditability, code combined with service-level agreements, code combined with integrations, code combined with legal liability, code combined with institutional familiarity, code combined with someone to hold accountable when something breaks. That last one matters more than many people admit. Inside large organizations, trust is often defined not by perfection, but by accountability. Who approved this system? Who certified this system? Who supports this system? Who answers when this system fails? That is why the enterprise moat does not vanish overnight. Banks do not remove their core systems because a clever artificial intelligence founder posted a demo on social media. Hospitals do not move patient workflows onto a weekend-built agent stack because the technology looks impressive. Institutions move slowly because institutional failure is expensive. So yes, there is inertia. Yes, there is stickiness. Yes, there is a delay between technical possibility and economic reordering. But delay is not immunity. That distinction matters. The old gatekeepers are not necessarily finished. But the terms of survival are changing. And this is where the discussion became sharper. Because once it becomes clear that software creation is being commoditized, another question emerges. What becomes scarce next? That is the real question. What becomes the new bottleneck? What becomes the new premium layer? What becomes the resource people will pay for when software itself can be generated almost without limit? The answer began to appear from multiple angles. Trust. Not trust in a sentimental sense. Trust in an operational sense. Trust as verification, trust as authentication, trust as governance, trust as security, trust as reproducibility, trust as formal assurance, trust as a system for filtering signal from an ocean of machine-generated noise. That is the birth of the trust economy. Because once code becomes abundant, value shifts toward deciding which systems deserve confidence. Which code is safe? Which code is accurate? Which code is malicious? Which agent is authorized? Which model is behaving within policy? Which system has been audited? Which output can be relied upon in law, finance, healthcare, defense, identity, logistics, and national infrastructure? In other words, when software becomes infinite, trust becomes scarce. There lies the thesis, the frame, the entire conversation in one line. And once that is seen, the historical pattern becomes visible. Software economics has unfolded as a sequence of ages. First came the code era. In that age, the scarce resource was engineering capability. Organizations that possessed the programmers, the architecture, and the technical talent dominated the field. Then came the distribution era. Cloud platforms, software as a service, application marketplaces, workflow ecosystems. In that age, the scarce resource was access to users. Success depended on placing software in front of users, embedding it into workflows, and building systems difficult to remove. That was the age where platform owners thrived and where enterprise embedded software produced immense wealth. Now, a third era is emerging, the artificial intelligence era. And in this era, code generation becomes inexpensive enough that neither engineering skill alone nor distribution alone can explain the next moat. Because if artificial intelligence can generate endless tools and intelligent agents can increasingly navigate digital systems without human preference, then the true premium shifts. It shifts toward systems that verify, govern, rank, filter, and secure machine-generated action. Not just software, machine action. That distinction matters because the future challenge is not merely software complexity. It is autonomous systems acting across networks of decisions. Section 4. Human economics has always been built around human weaknesses. Branding works on humans, advertising works on humans, status signaling works on humans, interface stickiness works on humans. Humans tolerate friction, humans postpone switching. Humans remain loyal to mediocre tools because they are familiar, fashionable, or simply comfortable. But agents behave differently. Agents do not care about aesthetics. Agents do not care about logos, founders, keynotes, or marketing campaigns. An agent evaluates different signals: latency, price, reliability, permissions, performance, uptime, accuracy, policy constraints. A machine buyer does not possess brand loyalty in the traditional sense. It performs route optimization. So if the world begins to shift toward an agent-mediated economy, a large number of old business categories begin to weaken. Advertising becomes less powerful. Brand becomes compressed. User interface mystique weakens. Customer retention logic changes. Even application marketplaces begin to appear less permanent. Why? Because application marketplaces assume a human decision maker browsing options. A human browsing, a human comparing, a human selecting, a human downloading. But if an agent can dynamically assemble or route to the best tool for a task, the value of static storefronts declines. If software can be called, composed, or generated on demand, then distribution becomes less about prominent placement and more about trusted machine-readable interoperability. This represents a large shift. The future marketplace may not resemble a shopping mall. It may resemble a protocol field, an application programming interface coliseum, services competing in real time on measurable performance rather than psychological persuasion. If that environment develops at scale, the idea of the traditional software company begins to change shape. It may no longer be defined primarily by owning a single application. Instead, it may be defined by controlling a trust layer, a routing layer, an identity layer, a verification layer, a governance layer, a reputation layer. This is why the phrase trust economy captures the moment so clearly. It names the next substrate. Now, the framework becomes clearer. What exactly must be trusted? First, the code itself. Was it generated safely? Does it behave as expected? Has it been audited? Second, the model. Does it hallucinate? Does it leak sensitive information? Does it remain within policy boundaries? Third, the agent. Who authorized the agent? What permissions does it possess? What identity does it carry? Can its actions be logged and reversed? Fourth, the output. Can a recommendation, a decision, or an automated action be relied upon in high-stakes environments? And fifth, the system of systems. Can multiple autonomous components operate together without producing invisible systemic risk? That last issue will matter more than many anticipate, because the future danger will not necessarily be a single flawed model. The danger may emerge from the interaction of many autonomous systems operating simultaneously inside finance, infrastructure, supply chains, healthcare, and governance, which means trust cannot remain an afterthought. It becomes infrastructure. Just as the internet eventually required encryption, identity verification, secure payments, and layered security architecture, the artificial intelligence economy will require trust architecture. And history often repeats a familiar pattern. The flashy product attracts attention. Infrastructure accumulates value. Now return to the earlier example. The earlier era rewarded organizations that mastered sticky enterprise software in a world where code remained scarce. Those strategies produced immense wealth. But the landscape now forming may reward a different capability: the ability to govern software once it becomes too abundant to trust automatically. That is the hinge. That is the pivot. The previous software economy monetized scarcity in code, talent, and deployment. The cloud era monetized scarcity in distribution, platform access, and workflow lock-in. The artificial intelligence era may monetize scarcity in trust, verification, governance, and machine-safe coordination. That is the through line. That is the map. And from that map, a final statement emerges. When code becomes free, the price of certainty rises. When software becomes infinite, the premium shifts to filtering. When autonomous agents can build, compare, and switch between tools in milliseconds, the winners are no longer merely those who produce software. The winners are those who certify reality. That is the business. That is the moat. That is the emerging architecture of power, the trust economy. When code becomes free, trust becomes the business. Flint West signing off.